P2.1, the strong nuclear force. So we have a picture here of a middle of an atom, nucleus. This is obviously quite a big one. It's got lots of neutrons in this picture represented by the grey spheres, and a lot of protons as well, represented by the red ones. Now, the problem with that is that protons repel each other. So you've got lots of things here with positive charge in very, very close proximity, very, very close to each other. So they're going to repel each other with a lot of force. So we need a stronger force to hold them together. So what is it? It's called the strong nuclear force. This is a graph representing it. It plots the force between nucleons here on the y-axis against distance apart, the nucleon separation, on the x-axis. So you need to know a few numbers. It's attractive between 0.5 femtometers and between 3 and 4 femtometers. And if you don't know what a femtometer means, it's 10 to the minus 15 meters. Okay, so that's that. Very, very small. We don't really use femtometers in any other branch of physics because it is so small, it's quite unusual. If you get any closer than half a femtometer, the force becomes repulsive. In other words, the nucleons won't squash into each other. They'll sort of get to a certain separation and then that's it. A bit like having a bag of marbles, I suppose. You can't squash the marbles into each other. So beyond about 3 femtometers, the force pretty much fades to nothing, and the repulsive forces of the electromagnetic repulsion take over. Okay, so this graph is important, and make sure you study it a bit before your exam. Okay, and try and remember those numbers.